Welcome you all. In this video we will see how we can build and visualize rectangular or gate pulse signal in MATLAB. So rectangular or gate pulse signal is a kind of signal where the signal is available for a specific period of time. And if you look at the shape of this signal, it looks like a rectangular or like a short pulse. That is why it is actually referred as a rectangular or a gate pulse signal, right? And it can be indicated in both the continuous time as well as discrete time. So in a continuous time, the signal can be mathematically written like this. So when the signal is available, whenever the time limits between, let's say, between minus t by 2 to t by 2, and all of the time the signal is 0. Similarly, in a discrete time, the signal is available between the limit of minus n1 to plus n2, and all of the time the signal is 0. So this is what actually a rectangular signal. Now let's see how we can build the signal in a MATLAB. So first we create a file and then we'll save. Let's name this as let's say rectangular signal. Okay, so as we do always, first we try to create a x-axis data. So from the previous example, I just take the same x-axis variable for a rectangle pulse also. I just rename this figure name as rectangular, right? Rectangular signal. Done. So also I just create a subplot because I wish to see the rectangular signal in both continuous time and discrete time in a single window, right? Okay, now we have to create a amplitude, right? So first we create an amplitude in a continuous time, right? So as you look here, and the rectangular signal is available for a specific period of time. So we can take this as a starting point and this is the ending point. So between this starting and ending point, the signal is equal to 1, and all of the time the signal is 0. So which I should create now, right? So now I should declare the starting point and ending point of my signal. So let's say for our case, let's consider the starting point as, let's say, minus 5 and ending point as plus 5. So I just declare the starting point as t start. Okay, t underscore start as a variable name. For that I am going to assign a variable minus 5. So minus 5 is the starting point, right? And then I just declared ending point as c underscore end, which is equal to, let's say, plus 5. Right now we have to make between this time limit, that is between minus 5 to plus 5, we should keep the amplitude as 1. So for that again I am going to use a logical operation. Okay, so let's have the magnitude as y1, which is equal to 1 whenever the t lies between minus 5 to plus 5. So for that I am going to use this here I am going to use as a logical operation. So I just keep now my t if whenever the t greater than or equal to starting point, right, which is t start, t start. So whenever the starting point is greater than or equal to t, right, then we should keep that y1 as 1. Okay, and also whenever the t less than the end point, time end point, for that condition also we should keep y1 as 1, right? So whenever both the conditions are true, then we should keep that y1 as 1, and all other cases we should keep y1 as 0. So I am trying to check the time whether the t lies between starting point to ending point. So whenever starting point is greater than or equal to t, and for AND operation in MATLAB we will be using a ampersand symbol, this symbol, right? And also when t less than or equal to end point, t underscore end, Okay, right? When these two conditions holds true, then y1 will be automatically assigned as 1, and for all other t the y1 will be assigned as 0. So I repeat, so in this command it checks whether the t lies between starting point to ending point. So we have declared already starting point as -5 and ending point as +5. So whenever t lies between this -5 to +5, it takes this condition as true, and that will be automatically assigned as 1 to the y1 variable. For all other cases it makes y1 as 0. Clear? So now we have created a amplitude. So now we go for plot. So let's use a plot command followed by x-axis, which is a t, and then y-axis, which is a y1, right? So this is going to create a rectangular signal in a continuous time. So now just we label the x-axis, y-axis, and also we make a title of the plot. So for that I use a previous program. So let's paste it and let's edit this. Right. So this is a rectangular signal, right? Okay, so this is actually a rectangular signal in a continuous time. Now let's try to do the same thing in a discrete time. So as we see here, in a discrete time frame, the rectangular signal is equal to 1 for a certain limit of between -n1 to +n2. So I just take that -n1 as a starting point and +n2 as an ending point. So I just take the same as we did for a continuous time. So let's take starting point in n. So let's keep that n start, which is equal to, let's say, -5, and n end, which take it as +5. Right? Now we have to keep an amplitude equal to 1 within a time frame of -5 to +5. Right? So let's take the magnitude as y2, which is equal to, so now I am going to compare as we did before. Now we have to consider the n limit, right? So we need to check for whether n lies between start to n. If it is so, then I should take y2 as 1, and all other cases y2 as 0. So whenever n greater than or equal to starting point, so n start, and also whenever n less than or equal to starting point, right? If this condition holds true, then it will automatically assign y2 as 1, right? So I repeat, here we are just checking whether n lies between start to n. So which means whenever n greater than or equal to starting of n, and also whenever n less than or equal to ending of n. So if both are holds true, then it takes y2 as 1, and all other cases y2 as 0. That is what actually rectangular signal is about, right? So now we have made a amplitude. Now we go for a plot. So for making a discrete plot, we should use a command called stem. First let's call the x-axis data, and then followed by the y-axis data, which is y2 in our case, right? Then we go for labeling the signal. Okay, right. So this is going to be sample. This is rectangular signal in discrete time, right? So let's save this and run this one. Oh, we are not actually declared a subplot, right? So we have to declare the subplot, right? So subplot (2, 1). I'm going to place this in a second place, 2, 1, 2. So right now save this. Right now you can see, so the first one is a rectangular signal in a continuous time, the second one is a rectangular signal in a discrete time. Thank you.